Children, some important questions in gravitation lesson I am discussing, children. If you know the answers, you can very much answer, children, or else just listen and try to understand. On what factors the acceleration due to gravity depends? Children, acceleration due to gravity, it depends upon poles, it depends upon equator, it depends upon the height. Okay, children, it depends upon the height, it depends upon the depth, it depends upon the mineral deposits. It depends upon the mineral deposits. Do you remember, children? We discussed in detail about this, children. In detail about this, it is children at poles because radius is less, acceleration due to gravity is more. I said at the equator because radius is more, acceleration due to gravity is less. I said as you go up from the earth, as radius is increasing, acceleration due to gravity decreases. As you go inside also, acceleration due to gravity decreases, and due to mineral deposits also, acceleration due to gravity decreases. So acceleration due to gravity, what is the formula, children? Gm by r square.
GM by
Gravity
R
is
square.
gravity is inversely proportional to radius. Gravity is inversely proportional to radius. Try to understand, children. Gm by r square. Second question, children. What will be the body weight more, 1 kilometer above the surface of the earth or 1 kilometer below the surface of the earth? Where is the body weight more? Okay, children, where will the body weight more? Is it 1 kg below or 1 kg above? Is it 1 kg below or 1 kg above, children? As you go down 1 kilometer below or as you go up 1 kilometer above, where will the body weight more, children?
Sir,
Body
down.
Down.
down only, children. This cause as you go up, acceleration due to gravity keeps on decreasing. Of course, as you go down also it decreases. First initially decreases and then decreases, children. What is the acceleration due to gravity at the center of the earth? As you go to the center of the earth, children, at the center of the earth, acceleration due to gravity is zero. At the center of the earth, acceleration due to gravity is zero. Okay, children. Next, state universal law of gravitation. Two bodies, two heavenly bodies separated by distance are, the force of attraction or repulsion between them is directly proportional to product of their masses and inversely proportional to square of the distance between them. Remember proportionality constant, keep a constant g, where g is called universal gravitational constant. Okay, children, the force of attraction or repulsion is directly proportional to product of their masses, inversely proportional to square of the distance between them. The force of attraction or repulsion is directly proportional to product of their masses, inversely proportional to square of the distance between them. That is called universal law of gravitation. We studied that derivation also, children. What do you mean by free fall? Anyone in the class? What do you mean by free fall?
Sir, an object which is dropped at height without throwing it, sir.
No, not like that. Anyone? What do you mean by free fall? Anyone in the class?
Sir, an object it is reaching a certain height and drops from there.
What do you mean by free fall? Anyone in the class?
Object falling freely.
Hey.
An object dropping from a height with initial velocity is zero.
U is zero, initial velocity is zero. If a body initial velocity is zero, that is called free fall, drop. What, children, after discussing so many classes, so many things, free fall means you are not able to say. What is acceleration of the free fall? Any freely falling body, what will be its acceleration?
9.8, sir.
Gravity.
Acceleration same 9.8 meter per second square. What do you call the gravitational force between Earth and object? What is the gravitational force between Earth and object is called? Force of
Force of attraction. Uh,
gravity.
gravity.
Okay, the gravitational force between Earth and object. State two factors on which gravitational force depends. State two factors on which gravitational force depends. On mass and distance.
Distance.
On mass and distance between them.
Mass and distance.
On mass and distance between them. Next, what is the value of big G? Where is big G? Big G. What is the value of big G?
6.67 into 10 to the power 11 minus 7.
Minus 11 Newton meter square.
Newton meter square kg square.
Per
By
kg
kg
square. Newton meter square per kg square. Newton meter square per kg square.
Kg
Give an example of motion of object under the influence of gravitational force. Give an example of motion of object under the influence of gravitational force. Is there any body moving under the inflation of gravitation of Earth? Is there any body moving?
Moon.
Moon is moving under the influence of gravity of the Earth, and Earth is moving because of
Sun.
Sun,
sun.
sir.
Earth is moving because of sun. Moon is moving because of Earth. What is weightlessness? If I say weightlessness means what? Anyone? Weightlessness means what? Weightlessness means what? Anyone?
Sir, where the acceleration of due to gravity.
Gravitation is equal to 0.
Gravitation is zero. Very good. Acceleration due to gravity is zero. Okay, Vivek and Snigdha, very good. So acceleration due to gravity is zero means what is the formula for weight? Mg. So m into zero, zero. Weightlessness means acceleration due to gravity is zero. Next, state the universal Newton's universal law of gravitation. Newton's universal law of gravitation states that force is directly proportional to product of their masses and inversely proportional to the square of distance between them. Remove proportionality, keep a constant. Okay, so in this one more bit is there. Express the universal law of gravitation mathematically. What is mathematical? F is equal to G
Equal
m1
to
m2
G m1 m2 by d square.
d square or r square. What is the units and value of acceleration due to universal law of gravitation? This is called universal gravitational constant. This is called universal gravitational constant. That is f d square by m1 m2. F d square by m1 m2. Newton meter square by kg square. Newton meter square by kg square. Okay, what is its value?
6.67 into 10 to the power of minus 11.
6.67 into 10 to the power of minus 11 Newton meter square by kg square. Newton meter square by kg square. You should know, children. Okay. Next question. Why value of G is greater at poles than the equator? At poles, acceleration due to gravity is more than the equator. Why he is asking? This is the question. Why means
Sir,
polar
actually,
radius.
sir,
Yeah.
Earth is not in a perfect spherical shape. It is a bit oval. In near the poles,
Near the pole, R is
the
less,
poles are nearer to the center
and
of the
no,
Earth.
equatorial radius is more, polar radius is less. We know G is equal to Gm by R square. We know G is equal to Gm by R square. If radius is less, G will be
Increase.
more. Okay, children. If radius is more,
G will be decreased.
G will be less. Like that, children. Try to understand, children. Next question, children. Um, Explain the activity show that during free fall, heavier and lighter objects accelerate with the same ratio, same rate. During a free fall, whether it is heaviest object of 100 kg or just a feather, both fall at same rate. Take a vacuum chamber, children, take a vacuum chamber and liberate 100 kg and feather. Both of them will fall at the same time, indicating that the only force acting on them is acceleration due to gravity. So both of them will fall with the same speed and same time, children. Same time they will fall. They both fall. If it is vacuum chamber, if it is vacuum chamber, but in the air resistance, that this also will play a vital role. But in vacuum, 100 kg and even a feather also fall at the same time. This is a small activity you have to show, children. Okay. Next, what are the difference between mass and weight? Children, so many times I discuss this question, children. What are the difference between
Sir,
mass
mass is
and
constant, weight is not constant.
Not constant.
mass is always constant. Weight changes according to G.
G.
Gravity, sir.
Mass units are kgs. Weight units are
Newtons.
newtons. Mass is scalar. Weight is
Vector.
vector. Weight is a vector. Mass is measured by common balance. Weight is measured by
Scale.
Scale.
spring balance.
Spring balance. Spring balance.
Scale rate, the fellows. Mass is the matter contained in the body. Mass is the matter contained in the body, and weight is the force with which Earth attracts all the bodies towards it. Weight is the force with which Earth attracts all the bodies towards it. Okay, so the difference between mass and weight. This is M, this is W, and what is the formula for weight? W is equal to mg. Next,
Mg, sir.
why is Newton's law of gravitation called universal law? Why Newton's law of gravitation is called universal law? Means it is applicable to every object on the universe. Newton's law is applicable to every object on the universe. What is Newton's law, children? He said that force is directly proportional to product of masses. He said that force is inversely proportional to square of distance between them. Combining both F is directly proportional to m1 m2 by d square. Remember proportional to F is equal to g m1 m2 by d square. So this is universal law of gravitation and this is universal gravitational constant. This law is applicable to every object on the universe. That's why it is called universal law, children. Write four phenomena which were successfully explained using universal law of gravitation. What are the things which are explained successfully using universal law of gravitation? Number one is that force that binds the earth. Earth is bounded by sun's gravitational force. The motion of moon is bounded by earth gravitational
Earth's gravity.
field. Motion of the planets, all the planets are held by sun's gravitational field. And high tides and low tides are in the oceans and seas and rivers occurs because of moon's gravitational
Moon's
pull.
gravity, sir.
Moon's gravitation.
Moon's gravity. So all these things are clearly explained using universal law of gravitation. Newton's universal law of gravitation. This is the derivation, children. This is the derivation. You should know it. Okay, children. Next question. Next is, please children, mute your audios if you're doing any work. State the source of centrifugal force that planet required to revolve around the sun. Children, our earth is moving around the sun. Children, our earth is moving around the sun. Earth is moving around the sun. What is the centrifugal force which is binding them, children? Centrifugal force which is binding them? Sun's gravitational field. What is the centrifugal force? Centrifugal means, children, see, if ever any body is rotating in the circle, outward force is called centrifugal force, children. Outward force is called centrifugal. Inside force is called centripetal. If they both balance each other, then only you will rotate in the circle. If they both balance each other, then only you will rotate in the circle. If not, if outside force is more, it moves out tangentially. If inside force is more, it comes and drops in the middle. If both are equal, then it keeps on rotating. So who is giving centripetal force between the sun and earth means it is the gravity of the sun. The gravity of the sun is holding the earth. The gravity of the sun is holding the earth, children. Okay, next one. They have an expression for universal law of gravitation. Till now I told 10 times. The force is directly proportional to product of mass, inversely proportional to square of distance between them, combining both m1 m2 by d square, remain proportionally constant g, where g is called universal gravitational constant. Where g is called universal gravitational constant, whose value is 6.67 into 10 to the power of minus 11 Newton meter square by kg square and Newton meter square by kg square. G is called what, children? Universal
Universal law of
gravitation.
gravitation.
No, not
Universal
law.
gravity.
Universal gravitational constant. Universal gravitational constant. What is the differences between small g and big G? What is the difference between small g and big G? Small g is 9.8, big G is 6.67 into 10 to the power of minus 11. What is the units of small g? Anyone? Acceleration due to gravity units?
Meter per second square.
Meter per second.
Meter per second square. Big G units, anyone?
Then Newton meter square.
Newton meter square by kg square.
Newton meter square per kg square. It changes. Small g changes from place to place. Big G is constant all over the universe, not only world, all over the universe. That's why it's called universal gravitational constant. And the formula for small g is W is equal to mg. And formula for big G is F is equal to G m1 m2 by d square. Okay, children, these are the differences between small g and big G, children. And remember, children, small g is vector quantity, children. Small g is vector. Acceleration is always vector. Why acceleration is vector? Because velocity is vector. Why velocity is vector? Because displacement is vector.
Because displacement is vector.
And big G is scalar, children. Big G is scalar quantity. Big G is scalar quantity. You have to remember this, children. Next, define acceleration due to gravity. What is meant by acceleration due to gravity? Okay, the acceleration due to gravity means is the force with which Earth attracts all the bodies towards it. What is acceleration due to gravity? Is the force with which Earth attracts all the bodies towards it. We know what we know. Universal law of gravitation. F is equal to G m1 m2 by d square. Am I correct, children? F we can write as mg. F we can write as mg. Okay, children. One m cancel. So small g is equal to gm by d square or r square, children. Small g is equal to gm by r square or d square, children. Okay, so this is relationship between small g and big G. What is the relation between small g and big G? Gm by r
Yes, by
square.
r square.
Gm by
What
r
is
square is the relationship between small g and big G. What do you mean by acceleration? What is the value of acceleration due to gravity on the earth, children? On the earth, how much?
9.8
my
Meter per
meters
second
per
square.
second square.
On what factors G depends? Now only eight, right? Height, depth,
height,
Height,
poles,
mass,
equator,
mass.
minerals. Height, depth, poles, equator, minerals. Height, depth, poles, equator, mineral deposits. On what factors the value of G depends? I told you. That's all. Okay. Okay, children. Suppose if a body, children, you are taking a thread and you are rotating a stone in your hand. Okay, a stone is rotating now, children. The inside force is called what I told? Inside force?
Centripetal force.
centrifugal force,
Centripetal force. Okay, and outside force is called
Centrifugal force.
centrifugal.
centrifugal. Outside force is called centrifugal force. Inside force is called centripetal. Children, next. Do the gravitational forces obey Newton's third law of motion? Gravitational forces, do they obey universal Newton's third law? For every action, there is equal. What is happening, children? Be careful, children. Behave yourself in the class, all of you. For every action, there is equal and opposite reaction, children. Do gravitational forces obey Newton's third law, means, children? Yes.
Yes,
Yes,
sir.
children. They obey Newton's third law, children. We can, in fact, derive also, children. In intermediate, they will show how to derive. What is the ratio of the forces between two masses kept at certain distance in A, the force between them when kept in any other medium? Whatever may be the medium, children, force is same. F is equal to G m1 m2 by d square. Whatever is the medium, whether it is air or whether it is vacuum or whether it is anything, the force between them is G m1 m2 by d square only. So the ratio is 1 is to 1 only, children. G m1 m2 by d square. Always remember. Okay, children. So some more questions are there, children. We'll discuss in the next classes, and especially about maximum height attained by the body. There's so many things are there. We'll discuss in the next class, children. Okay, and we'll do some maths.